Previously on Chemistry Z, our heroes discovered just what acids and alkali were. They also clocked the pattern between concentration of hydrogen ions in solutions and the pH number of that particular solution. But just when they were getting the hang of the different salts made in each reaction, they were attacked by the ions splitting up in the aqueous solution. However, through the power of friendship and spectator ions, they were able to write not only the ionic equation, but they leveled up and wrote the half equations as well. And now, our heroes have reached the second to last lesson of Chemistry 1 and will gain the secret knowledge of electrolysis. Will this challenge be too shocking for our heroes to handle? Find out in today's episode of Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. A solution with lots of hydrogen ions has a low pH. The acid that makes copper sulfate is sulfuric acid. Concentration is measured in moles per decimeter cubed. TMV stands for tobacco mosaic virus, so it's a virus. Enzymes are biological catalysts and they denature when their active site changes shape. You will remember this from my lesson on giant ionic structures. Yeah, boy. But it's also relevant for this lesson as well, so spend some time answering these challenge questions. The states of matter that we have here are solid, liquids and aqueous. The one missing here is gas. And looking at the light, it is off when the ion is in the solid state, so solid ionic compounds do not conduct electricity. This means that the state in which the ionic compound conducts electricity is the liquid and aqueous state. The reason for this is because the ions are free to move around and so can carry the electrical current. That means that we need to do two things in order to make ionic compounds conduct electricity. We can either dissolve them so that they're aqueous, or we can melt them so that they're molten liquids. Again, this is so that the individual ions are free to move around, and when charges move, that is a current. So by the ions moving around, we can pass an electric current through it. Alright. We have an ionic compound that has ions that are free to move around, and we add electrodes to this liquid, and these are usually made from graphite. More on that in a second, okay? The charge on each electrode depends on how the electrode is connected to your battery or power pack. The one connected to the positive end is positive, obviously, and the one connected to the negative end is negative. In your exam, the symbol for the battery will look like this. This is two or more cells combined together. The way to clock the positive and negative end is to look at the longer line. The longer line is your positive side. I remembered it this way. The negative and positive sign both have a horizontal line of the same length, but the positive line also has a vertical line as well. So if you join those two lines end to end, the positive end is longer. Now, you know what to do when you see these colors. The sodium ion is the positive ion, and remember they are called cations, so the chloride ions are negative, so they are called the anions. Check out my video on ions for more information on that. For the next question, you need to remember that oppositely charged ions or oppositely charged particles attract each other. So the positive cation will move to the negative side and the negative anion will move to the positive side. Finally, if ode means like, that means that cathode likes cations and anode likes anions. The cations are attracted to the negative, so the negative is the cathode. and the anions are attracted to the positive, so the positive is the anode. You can also remember this from the acronym PANIC. This stands for positive anode, negative is cathode. Now the ions don't move just for fun. Let's look at the name electrolysis. The electro part obviously comes from electricity, and lysis comes from the word for freeing up or breakdown.
Sensational.
The definition that you need to write in your exam is the breakdown of a substance using a direct current. If it's 2 marks, then you should get all of your marks by using breakdown using direct current, okay? This means that it's not enough for the ions to just move to the electrode. A chemical reaction also needs to happen, and the chemical reactions are basically just the movement of electrons. Let's look at what happens at the cathode first. The sodium ions currently have a plus charge and so gain an electron to become a sodium atom. Notice that the charge is now gone. At the anode, the chloride ions need to become a chlorine molecule, and so they lose an electron each. If you need a refresher on why chlorine travels as a molecule, check out my video on halogens for that. The next bit is part of the higher paper. We can write out the reaction. We first start with the sodium and chloride ions. I'm showing the molten sodium chloride here, which is why it is in a liquid state. If it was dissolved, it will be in aqueous states, okay? And at our electrode, that forms solid sodium and chlorine gas. First, we have to balance our equation. Check out my video on balancing equations to see why this is the balanced equation. I won't go into it on this video. Now, for our half equation, sodium starts off as a cation and then becomes an atom. There are 2 ways that you may get this half equation. The first is the unbalanced version, so 1 sodium cation forms 1 sodium atom. Remember that the sodium ion gains an electron, and so we add an electron to the sodium cation on the left hand side. The second way is getting this in a balanced form, and so you have 2 sodium ions forming 2 sodium atoms. Spend some time to complete this half equation. Now we have 2 positive charges on the left hand side, so we need 2 electrons, 1 electron for each sodium plus 1 ion. There's only one way to complete the half equation for the chlorine molecule. Spend some time figuring out how this should look like. It's a bit trickier. All I'll say is that remember that the electrons repel each other, okay? Electrons repel negative charges. When you're dealing with anions, so negatively charged ions, the electrons goes on the opposite side than where the anion is. So if the anion is on the left hand side, our electron will be on the right hand side. And since we have an overall charge of 2 negative on the left, we need 2 electrons on the right.
It's simple now. Look. When I tell you to open your eyes and learn, do not listen.
Alright, based on all of that, complete these half equations. The electrons are on the same side as the cation, so it will be on the left hand side. We have 2 plus charges, so we need 2 electrons on the left hand side here. The next one is also a cation on the left hand side, so the electron goes on the left hand side, but we have 2 lots of 1 plus charges, so we need 2 electrons on the left hand side. The next one is an anion on the left, so we need our electrons on the right hand side. The negatives will repel. We have 2 lots of 1 negatives on the left, so we need 2 electrons on the right hand side. And finally, we have this monstrosity here. We have an anion on the left hand side, so we need our electrons on the right hand side. First things first. We have two lots of 2 negative charges, okay? That means we have 2 times 2 negative charges. We have 4 negatives on the left hand side, so we need 4 electrons on the right hand side. Now try and work out which one of these are oxidation reactions and which ones are reduction reactions. Oxidation is loss and reduction is gain. The first one is gaining electrons, so that's reduction. The next one is also gaining electrons, so that's reduction as well. The next one is losing electrons, so that's oxidation. And the last one is also losing electrons, so that's also oxidation. Okay, Jaden.
What are you saying?
Tatiana.
Yes, uncle?
I'm gonna give you guys the ultimate, the legendary half equation to balance. You lot at home, yeah? Look at how my youngers are gonna do this and use that to help you solve future half equations.
What the hell is this? Why is there bare things here?
Yeah, uncle, I'm confused.
This is the only hint I'm going to give you guys, okay? You only have to worry about the electrons. Just follow the same steps that I did before.
Okay, we have an anion on the left.
Oh yeah, so the negative charge will repel, right?
That means that our electrons go on the right hand side.
Is that right, uncle?
Finish the thing.
I'm just gonna guess still. There's 4 electrons on the right.
What do you think, Tatiana?
Yeah, so each hydroxide is 1 negative, so we should have 4 electrons on the right hand side, right?
Very good. This is by far the hardest half equations that you will ever get in your GCSE. But again, since it's an anion on the left hand side, we need our electrons on the right hand side. And since we have 4 lots of negative charges on the left, we need 4 electrons on the right. Good stuff.
Nice.
Electrolysis is used to extract substances from compound. Let's bring back the reactivity series from a couple of lessons ago. I've changed it slightly so we've got aluminium in here as well. Remember that carbon is used to extract zinc, iron and copper. That means that all the metals that are more reactive than zinc have to be extracted using electrolysis. To prepare you for the next set of activities, have a go at these questions. It should be pretty straightforward. The substance is called sodium chloride. The metal ion is sodium ion, and the metal ion will move to the negative electrode, which is the cathode. When you have an ionic compound, the first part of the name comes from the metal, and this is always the cation. Metal ions always move to the cathode. Here I have 3 different molten substances. I've got these 2 challenge questions. You know what to do. Remember that metal ions, the first part of the name, goes to the cathode. So lithium, sodium and potassium are formed at the cathode. That means chlorine, bromine and fluorine are formed at the anode. The lithium ion would gain an electron to become a lithium atom. The 2 chloride ions will both lose an electron to form a chlorine molecule. The sodium ion will gain an electron to become a sodium atom. The 2 bromide ions will lose an electron to form a bromine molecule. The potassium ion will gain an electron to become a potassium atom. And the 2 fluoride ions will lose an electron each to form a fluorine molecule. This is when we have molten substances. Things get a little bit tricky when we have aqueous solutions. To get this on lock, you have to remember that aqueous means dissolved in water, okay? So for example, If we have lithium chloride, we not only have the lithium ions and the chloride ions, we also have the hydrogen ions and the hydroxide ions from the H2O of water. To work out what's formed at each electrode, because now we have 2 cations and 2 anions, we have 2 rules to follow. The first rule is this: if the cation is more reactive than hydrogen, hydrogen is formed at the cathode. The second rule: halogens are formed at the anode. If no halogen is present, then oxygen is formed at the anode. I know that looks mad confusing, but watch what this looks like. To work out the first rule, we need the reactivity series again. Hydrogen is all the way over here, so lithium is way more reactive than hydrogen. That means that it's hydrogen that is formed at the cathode where it gains an electron. Hydrogen is a diatomic molecule, so 2 hydrogen ions make 1 hydrogen molecule. Chlorine is a halogen, so that will be formed at the anode. And remember that halogens are also diatomic, so 2 chloride ions lose 1 electron to form 1 chlorine molecule. I know that was a lot of information, but I've got a cheat code for you.
You naughty, you teasing me, you naughty.
Instead of remembering all of the reactivity series for rule 1, if you have anything other than copper as your cation, then hydrogen is formed. Think about it. You can only form hydrogen or copper because it is only copper that hydrogen is more reactive than. So if it was copper instead of lithium, copper would be formed at the cathode. And for rule 2, you either are forming a halogen or oxygen. If the anion is in group 7, a halogen, then it is what is formed. Anything else, if it's anything other than something in group 7, then oxygen is formed. I'm gonna give you a test on a few solutions now, so go back to the beginning of this section if you need to refresh what I've just gone through. Have a go at this example. We've got an aqueous solution of this molecule here. And well, since it's an aqueous solution, we have our hydrogen ions and our hydroxide ions as well. At the cathode, either copper or hydrogen will be formed. We don't have any copper here, so it will be hydrogen that's formed at the cathode.
See? When I'm telling you that what they want is to bring us here and punish us, you did not believe. Now you see?
No, I didn't lie. Cobalt is CO, okay? The lowercase o. Cu lowercase is copper. So we are forming a hydrogen molecule, alright? If you see Cu, that's copper. Co is cobalt, but you've got your periodic table there to always reference. Iodine is a halogen, so that's what's going to be formed at the anode, okay? We form our diatomic iodine molecule. Let's do 2 more. This one should be a little bit more simple. Well, again, it's an aqueous solution, so we have our hydrogen and hydroxide ions. At the cathode, it's either copper or hydrogen forming, remember? Do we have any copper here? Yes, we do have copper ions here, so it will be copper forming at the cathode. And that forms a copper atom by gaining 2 electrons. Metals don't form diatomic molecules, so it's just going to be the regular copper atom, okay, after gaining those 2 electrons. And at the other side, we do not have a halogen, so oxygen will be formed. We've got a hydroxide ion that will form 2 lots of oxygen bonded in a molecule. Last one. Look carefully at this one and have a go. We only have to worry about these 2 rules if we're using aqueous solution, but this substance is molten. That means that we don't have our hydrogen or hydroxide ions. That means magnesium, our cation, will be formed at the cathode, and that gains 2 electrons to form a magnesium atom, and oxygen, the oxide ions, will go to the anode. and that forms our diatomic oxygen molecule.
You smart.
This last part of electrolysis is all about how we extract aluminium. It takes a lot of energy to make aluminium oxide molten, so we add something called cryolite to lower the melting point of aluminium oxide. The name cryolite literally comes from the Greek word cold stone. That could help you remember that it's used to lower the melting point of aluminium oxide. Then the aluminium ions are attracted to the cathode and gain 3 electrons to become an aluminium atom. The oxide ions then move to the anode, losing 2 electrons to become an oxygen molecule. There is just one more thing here though. Remember that I said that the electrodes are made from graphite, and we saw in the previous video that graphite is made from carbon. What happens then is that the carbon from the electrode is going to react with the oxygen molecules, forming carbon dioxide. What that means is that the anode needs to be replaced regularly because the carbon in the graphite reacts with the oxygen being formed at the anode to form carbon dioxide gas. So you're breaking apart that graphite electrode. And there we go. Lesson is done.
Fatality.
Check out my video on the electrolysis required practical over here. Use the timestamps to skip to any part that you need to go to and rewatch, because this was a long episode. I mean, it took me a long time to record this one. And check out the descriptions for the flashcard and also the revision timetable if you haven't got it already. And I'll catch you guys in a bit.